Now let us see the demo for video demonstration for the 10th program, that is linear and circular convolution. So I told you that 10th and 11th programs are non-real-time experiments. So let us see this particular. So as per the procedure we have discussed, let us start this particular Code Composer Studio first. So maximize this particular this one. So it will show first of all no target connected. So no target connected is displayed. So go for debug connecting the target. So first connect the target. So target is not, the message now is displayed as target is now connected. Okay, disassembly will open here. Just I told you that previous program whatever you have there, that will open. Just close this particular thing. Just close this. So after this, go for creation of new project. So linear and circular convolution is that use your 10th program, but you have to create separate projects for linear convolution as well as circular convolution. So separate project should be created for linear convolution, and one more project is created for circular convolution, because two programs you cannot work, you cannot two source files you cannot work under one project. So first of all, let us create a project for linear convolution. So for that project new, let us go for creating a new project named linear conv project -project or linear services project, linear conv project. I told you the target should be already 67XX. So click finish here. So two things are same. The location is CC Studio my projects linear convolution underscore something. So CMS C20 C67XX. Finish that. So whenever you click finish, automatically a named project name linear convolution -project will be automatically created. That is the automatic process. So go for file new source file. So file new source file. So you have to type your program. You have to type your program here for doing this. So already the typed program is there. Okay. So but you have to, all of you must type the program in your this. Otherwise, you don't get to know about the errors. To get to know the errors, you need to type your program. Okay. So this is your linear convolution program. Right. So this is the linear convolution program. So first of all, you are initializing y of 20, total number of elements, integer m is equal to 6, n is equal to 6. So int I is equal to 0, j, x of 15 is equal to 1, 2, 3, 4, 5, 0, 0. You are padding the zeros here. You are taking two sequences, 1, 2, 3, 4, 5, 6, another 1, 2, 3, 4, 5, 6. Then you are using a for loop for I is equal to 0, for I is less than m plus n minus 1 I plus plus. So it's y of I is equal to 0, for j is equal to 0, j is less than or equal to j plus plus. So this is the logic for performing the linear convolution. All of you are proficient in C language, so you can go through this particular logic of this one. Okay. So this is your source file. So what we discussed, immediately after typing the source file, you need to save this source file. So go for file save as. So you have to keep your cursor in the source file. Then only you have to go to file save as. So go for file save as. So wait, it is give some name here, linear.c something. So give us this source file this way. Where you have to save, go for the location, which is my projects. So now our current project is linear convolution underscore project. So go for this and save this. So with extension linear.c. So you can give any name. So linear.c is extension, save that. So after saving this particular this one, it will appear here, linear.c will appear on the menu. So first of all, after saving that, you need to add three files I told you. One is the source file, second one is the library file, third one is the linker command file. So go for add files to project. Go for first you add this particular linear.c. So linear.c is added to your project. Okay. Next is addition of your library file. The path of a library file is C drive CC Studio C6000 CG tools lib. Okay, C6000. Once again I will show you the path. Just remember this path. C drive CC Studio C6000 CG tools lib. In this you have to select object and library files. So under this you have got rts6700.lib. Under this you have rts6700 e.lib is also there. This is a wrong file. So the right file is rts6700.lib. Just select that and click open, or just double click that so that the library file is get added in this particular this one. So now the library file will be added to your project. After adding the source file as well as library file, go for once again add files. You have to create the linker command file. So go for creating the linker command file. For this you go for C drive CC Studio tutorial. Go for tutorial. Okay, once again I will show you the part. C drive CC Studio tutorial DSK6713 hello1 folder. In this hello1 folder, select linker command file. So linker command, whenever you click linker command file, automatically a file named hello.cmd will be there. So just open, so click on so hello.cmd will be. This is, you open this, it will show all the memory allocations, all this thing. This is a linker command file. Be careful that you should not make any modifications in this particular command file, because if you make any modifications, your program is not going to work. These are all supporting files. Don't worry, these supporting files will be given in your this at the time of examinations. So what it is, you are bothered only about the source file. Whatever the modifications are there, you need to do only with your source file. So now go back to linear.c. Now start. Now I told you that you have to do three. This one is compiling file, next rebuilding this one, and go for rebuilding. So you can also go for project compile file. Okay, project compile file, project build, and project rebuild. You can also go for that. This is the direct way. So first, if you compile the file, whenever you compile the file, it will show compile complete, 0 errors, 0 warnings, etc. Next is go for building. So already we discussed that building is for converting your source code into the assembly code. Next one is rebuilding your project. Right. So after this rebuilding, compiling, building, rebuilding, we discussed that the next task is go for file load program. You have to load your program in the DSP kit. So for that you go for this one, linear convolution underscore project. Go for debug folder. A .out named file having the same name of project will come. You can see here, linear conv dash project is the .out is going to come. Just open that, just double click that and add this particular this one. So now it will show I added this one. Now I have added your source file, you have a program to your kit. The next thing is seeing the output. You can go for this run option, or you can go for debug run. Anything you can select. Debug run is there, or press F5 on the keyboard. These are the options. So run symbol is there here. You can go for run, or you can go for debug, and then run option is there, or press F5 on the keyboard. So for simplicity, just run symbol is there. Click run symbol. So automatically you can see all the samples, linear convolution samples that are coming: 1, 4, 10, 20, 35, 56, 70, 76, 73, 60, 36. So what is the length of the output sequence? 11, because 6 plus 6 minus 1. L1 plus L2 minus 1 will be the length of the output sequence. This will be the length of the output sequence. Suppose you want to make some small modification in this. Suppose instead of \n, you want to declare \t, let us say, so that the samples are displayed side by side adjacently. So make a small modification, then save this once again. So whenever you make small modification, even if you make small modification, compile, building and rebuilding option is compulsory. So go for compile file, next go for rebuilding file, next go for rebuilding file. So whenever you click compile, build, rebuild, after that go for once again file load program, and then .out file. Double click .out file. So after this double clicking .out file, just click this run option. You can see the output here. You can see this output here. See this, the samples are displayed 1, 4, 10, 20, 35, 36, 70, 76, 73, 60, 36. The samples are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is the length of the output sequence. The samples are displayed adjacently side by side. So if you click the \t, the samples are displayed side by side. So this is the logic of your for this one, linear convolution program. Okay, right. So this is your linear convolution program. So now you can go for debug. So once again you want to basis, once again load the program, once again stop running, once again do this. Okay, once again load the program. Suppose you want to leave the program once again load the program, and then go for linear convolution .out. Then once again click run option. Once again the output is displayed. Okay, so like that. So how many times you want to run, that many times you will switch. Okay, like this.